objects we call the black holes could exist. But let me actually linger on
Yeah,
this.
that's incredibly interesting. Yeah,
There's a lot of interesting things here. First,
yeah.
the speed limit. How wild is it to you if you put yourself in the mind in the time of Einstein before him to come up with a speed limit of that there is a speed limit that and that speed limit is the speed of light? How difficult of an idea is that? Isn't it? You said from a mathematical physics perspective, everything just kind of falls into place, but he wasn't perhaps maybe initially had the luxury to think mathematically. He had to come up with it intuitively, yes? So like how counterintuitive is this notion to you?
Well,
Is it still crazy? What
no, no. So it's a very funny thing in physics. The best discoveries seem completely obvious in retrospect.
yeah.
Even my own discoveries, which of course are far lesser than Einstein's, but many of my papers, many of my collaborators get all confused. We'll try to understand something. We say, we've got to solve this problem. We'll get all confused. Finally, we'll solve it. We'll get it all together. And then all of a sudden, everything will fall into place. We'll explain it. And then we'll look back at our discussions for the precedings of months
Hmm.
and literally be unable to reconstruct how confused we were
Yeah.
and how we could ever have thought of it any other way.
That's so
And so
fascinating.
not only can I not fathom how confused Einstein was before when he started thinking about the issues, I can't even reconstruct my own confusion from 2 weeks ago. So the
Yeah.
really beautiful ideas in physics have this very hard to get yourself back into the mindset. Of course, Einstein was confused about many, many things. Um, doesn't matter if you're a physicist. It's not how many things you got wrong. It's not the ratio of how many you got wrong to how many you got right. It's the number that you got right. So Einstein didn't believe black holes existed, even though he predicted them. And I went and I read that paper, which he wrote. Einstein wrote down his field equations in 1915,
Hmm.
and Schwarzschild solved them and discovered the black hole solution 3 or 4 months later, in very early 1916. And 25 years later, Einstein wrote a paper. So with 25 years to think about what this solution means,
Yeah.
wrote a paper in which he said that black holes didn't exist. And I'm like, whoa, you know, if one of my students in my general relativity course wrote this, I wouldn't pass them.
You get a C minus. Oh, you wouldn't pass him. Okay. All right.
Get a C minus. Okay. Same thing with gravity waves. He didn't believe.
Oh, he didn't believe in gravitational waves either?
He went back and forth, but he wrote a paper in I think 34 saying that gravity waves didn't exist because people were very confused about what a coordinate transformation is. And in fact, this confusion about what a coordinate transformation is has persisted, and we actually think we're on the edge of solving it 100 years later.
Well, what
100 years later.
what is coordinate transformation as it was 100 years ago to today?
Let's imagine I want to draw a map with pictures of all the states and the mountains, and then I want to draw the weather forecast, what the temperatures are going to be all over the country.
Hmm.
And I do that using one set of weather stations, and I number the weather stations, and you have some other set of weather stations, and you do the same thing. So the coordinates are the locations of the weather stations.
Yeah.
They're how we describe where the things are. At the end of the day, we should draw the same map. That is coordinate invariance. And if we're telling somebody, we're going to tell somebody at a real physical operation, we want you to stay as dry as possible on your drive from here to California, we should give them exactly the same route, no
Sure.
matter which weather stations we use or how we,
Hmm.
it's a very trivial. It's the labeling of points is an artifact and not in the real physics.
Sure.
So it turns out that that's almost true, but not quite. There's some subtleties to it.
The statement that you should always have the same, give at least the same kind of trajectory, the same kind of instructions, no matter the weather stations.
Yeah, there's some very delicate subtleties to that, which began to be noticed in the 50s. It's mostly true, but when you have a space-time with edges, it gets very tricky how you label the edges.
In space time, in terms of space, or in terms of time, in terms of everything, just space time.
Either one,
Okay.
space or time. That gets very tricky. And Einstein didn't 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 have it right. And in fact, he had an earlier version of general relativity in 1914, which he was very excited about, which was wrong. It wasn't fully coordinate invariant. It was only partially coordinate invariant. It was wrong. It gave the wrong answer for bending light to the sun by a factor of 2. There was an expedition sent out to measure it during World War I. They were captured before they could measure it. And that gave Einstein 4 more years to clean his act up, by which time he'd gotten it right.